right, so I got to tell you about Galileo. Galileo Galilei. Galileo Galilei is an Italian astronomer, scientist, physicist, amazing, amazing person. A real Renaissance man, literally. So he lives in the early, he's doing, publishing his astronomy work in the early 1600s. He's a contemporary of Johannes Kepler. They actually had some letters and some stuff back and forth and all this. And so he's the one that brings the telescope to astronomy. He's not the one that invented the telescope. The very first telescope with the lenses in the tube and all this was put together by some Dutch lens makers up in the Dutch Republic and all that sort of thing. He's down in Italy, so he's Italian. However, what he does is he finds out about this, whether he got a telescope or just descriptions of it, a little bit, some of the details are a little fuzzy, but whatever. He figures out the mathematical principles behind the telescope. He starts building his own telescopes, and then first of all, he builds telescopes that are far more powerful than anything these Dutch lens make. These guys are making spy glasses for your, Avasti me hearties. They're out there looking at pirate ships in the ocean. Galileo builds more powerful telescopes, and he points his telescopes up at the heavens. And then he starts telling people about this, and he starts writing books about this. So he's Italian. He develops the astronomical telescope. He points it up at the heavens, and he discovers stuff all over the place. He's the first person we've got, using a telescope to make astronomical observations, and it's just mind-boggling. Everywhere he points his telescope up at the heavens, he discovers stuff. He discovers amazing stuff. He discovers colossal stuff. And a lot of the stuff he discovers contradicts the old Greek view, but the old Greek view. Aristotle said that up in the heavens everything is perfect and eternal and unchanging. Everything's made of perfect spheres and moves in perfect circles, and this is where a lot of these Greek ideas are coming from. Galileo points his telescope up at the moon and he says, hey, there's mountains on the moon. By you looking at the shadows on the moon, you can see there's mountains and craters and all kinds of stuff going on there. So he makes all these discoveries. So Galileo discovers all kinds of stuff. He discovers mountains on the moon. According to Aristotle, the moon is supposed to be perfect. A perfect ball, blemishless, and it's got mountains on it. He points his telescope up at the sun. He discovers there's sunspots. He discovers sunspots appear and develop. He discovers the sun rotates. Sunspots. He carefully veils his telescope with silk veils before he points it at the sun. He didn't quite shield it enough. Actually, that's one of the reasons he eventually went blind, because he didn't have his telescope as shielded and as safe as he thought he did. But he discovers sunspots. According to Aristotle and the ancient Greeks, the sun is supposed to be this perfect orb. Well, it's not perfect. It gets these little spots and they go away. Sun's not supposed to have pimples on it. He points his telescope up, and what does he discover? He points his telescope up at Jupiter. He discovered there these four little star-like things next to Jupiter, and then when he observes the next day, they moved. And the day after that, they moved again. And he discovers that these things are kind of moving back and forth. Jupiter has moons. He discovers Jupiter's moons. He discovers 4 of them. He names, they're called Io, Europa, Ganymede, and Callisto. And they orbit around Jupiter. Io takes, a couple days to orbit around Jupiter. Here's all the way out to Callisto, which takes, more than a week, sort of thing like that. And they're orbiting around Jupiter. Already, that sinks this old ancient Greek view that all things move in perfect circles around the Earth. Well, these 4 moons orbit Jupiter. To say nothing about the orbit of Mars or anything like that, those moons go around Jupiter, so not everything goes around the Earth. He points his telescope up at Saturn, and he sees, in his writings, he says Saturn has ears or companions, or another time he said Saturn has arms. He's seeing the rings of Saturn, but his telescope isn't quite good enough to tell exactly what they are. So he discovers Saturn's rings. We'll give him credit for the rings, even though he never used the word rings. He used ears, he said arms, companions, but he's seeing stuff, and it's interesting. Saturn is not just a perfect ball, it's got some things next to it. Can't quite figure the details out about it. And then he points his telescope at Venus, and Venus is amazing. That really puts the nail in the coffin of the whole geocentric, Earth at the center, the Earth, all the planets moving in circles around the Earth. Venus really, that really changes things, because when he looks at Venus, what he finds is that Venus goes through a complete cycle of phases. Venus goes through phases just like the moon does. You can have a crescent Venus, and a gibbous Venus, and a quarter Venus, and a full Venus, and I guess a new Venus, because you wouldn't see that. And that complete cycle of phases would make no sense if Venus was going in circles around the Earth. Okay, so let's take a look at this. In the old Greek view, in the old Greek view, here's the Earth. There we go. We got the Earth. So there's the Earth, and we got all the planets moving in circles around the Earth, and these things are all moving in circles around the Earth, and the Sun also would move in a circle around the Earth. So here's the Sun. Here's Venus, moving in its epicycle. So there's Venus. And so Venus is moving around in its epicycle as the Sun orbits the Earth. And you'll notice that as you do this, as Venus goes around, it's always between the Earth and the Sun. In the geocentric model, in Claudius Ptolemy's ancient Greek geocentric model, Earth-centered model, Venus is always between the Earth and the Sun. And so, well, we know how phases work. You know, okay, if you're over here, the lit up side of Venus, well, that's the lit up side, it's lit up by itself. We should always kind of be seeing the night side of Venus. Now, it gets off to the side, so we should be able to see a crescent Venus. But Galileo said, hey, according to Claudius Ptolemy's model, Venus should always be in either new or crescent phases. You should never be able to see a full or a gibbous Venus, because we're always kind of looking, no matter where Venus is in its little epicycle thing going around in its deferent sort of thing, it's always between us and the Sun, so we should never be able to see anything more than a crescent Venus. But that's not what he saw. He observed that Venus could be full, could be gibbous. And so the only way, so he said, well, again, Galileo's a big fan of Copernicus. Galileo thought that the planets moved in perfect circles around the Sun, so he didn't quite get with Kepler's idea of ellipses. He kind of argued against that. But so let's see how that works. So if we put the Sun at the center, then we've got Venus going around the Earth, and then we've got the Earth in its orbit. So here's the Earth. The Earth right out here, and then Venus. Well, okay, Venus is going to go all the way around the Sun. Venus will take less time to orbit the Sun. So if Venus is, I don't know, over here, where there's the lit up side of Venus, the dark side, okay, we would see a crescent Venus from here. But if Venus is over here, well, then there's the day side and the night side, and then we could see a gibbous or a full, we would see a gibbous or a full Venus when Venus is over here. And so Galileo makes this wonderful argument, and he lays out the geometry of phases, and he says, all right, here it is. In order for Venus to be in the gibbous phase, it's got to be kind of on the other side of the Sun from us. And Claudius Ptolemy said it should never be on the other side of the Sun from us. And so this disproves Claudius Ptolemy's model. So there we go. That's an amazing, amazing sort of discovery. Galileo does other stuff. He does other stuff with motion and physics. He studies motion. Physics is the science of motion, so he studies motion. And he figures out, this great objection to Copernicus is that with the planets moving around the Sun, well, good grief, why wouldn't birds and clouds be left behind? And Galileo discovers inertia. He clearly writes out and explains this idea of inertia, that things which are in motion will tend to stay in motion. Things in motion tend to stay in motion. He said the reason why the birds and the clouds don't get left behind by the Earth is because, well, they're moving with us. It's that once you got everything moving together, they're just going to keep moving together. And yes, we're screaming through space at thousands of miles an hour, but the point is, since we're moving together, we don't notice the motion. He talks about if you got a ship sailing at sea and it's nice and flat, you got a cannonball up at the top of the mast and you drop that cannonball, will the cannonball fall behind the ship? No, it's moving with the ship. And as long as the ship is in motion, it's going to fall down and hit the ship right at the base of the mast. It's not going to be left behind because the ship was already in motion when it's dropped. Because you have this principle of inertia, then these objections to the ideas of the planets moving around the Sun, they go away. And so suddenly it makes sense. Galileo revolutionized our idea of astronomy and allowed the science of astronomy and physics to really get going.